In our session 1, what we saw was how we can create storage containers. So how we can save data in the containers in the form of single value container to store only one value and multi-value containers to store multiple values. So that was the part of model. So we got this architecture called model view controller. So model means data storage, where we understood single value containers and multi-value containers. So two things we just understood, and in both the parts we did see what is create, update, read and delete operations. So we saw these four major operations specifically in single value containers, but for multi-value containers we did see only create and read, right? So what is update, delete, that will specifically come up in our upcoming discussions. Now what was view here for us? So view for us as of now, view means GUI, but as of now view for us is console, that is textual interaction, which means, so we were using this function called input, right, where we ask the user, so we ask user on console to interact with our program, right? So this is what we were doing. Now today what I'm going to do is I'm going to take you guys to controller. So controller means logic, where in the logic we got two parts. The first part is computation. Second part is decision making. The third part is iteration or iterating, right? So we're gonna come up and today see what is meant by the term computation. Now, in our world, everything is mathematics, right? So I truly believe this point. So everything is maths. It's very simple for us to understand why and how. So time is maths. So when I go to my doctor, he wants to look into the reports. That is again mathematical structure. So everything in this world can be thought of maths, and we do a lot of calculations, computations to come up to a result. But how we do it, right? So in computer science, we got operators. So these are mathematical operators. So operators will help to process or slash execute a computation, right? So we need storage containers. So we have storage containers, and they contain data. So we can use operators on storage containers to perform some computation. So guys, this is how we're gonna work with the operators, right? And what I'm gonna take is a very small, let's say, discussion. Let's try to come up and take it as in networking part, right? So on a router, I can find a transmission delay. So there is a transmission delay which we can find, and that is basically what is the data size divided by the bandwidth, right? So this is one basic formula how you can come up and find the transmission delay. So let's say the data size is 200 and let's say the bandwidth is 8. So you're gonna come up with some output that's gonna work for us very easily. Now these are simple calculations which we can do, but why we need programs to come up and interfere when the data becomes complex. So if you have data which is something like this, and when you have a speed of something like this, now computing this is a bit difficult, right? So computation of you can say complex data becomes difficult and we compromise two things here. The first thing is time, right? So we utilize more time. Second thing is accuracy. So we might not be accurate as a human. So for simple values, that's perfectly fine. But when it comes to the complex values, it becomes difficult for a human to compute. Now that is the reason why we will rely on computers, on programs, that they should do the computation for us. So let us jump into our Python programming. So once again, I'll do right click on my project. Now this time I'm gonna say a new Python file, name it as session 2. So in this session 2, so we'll be exploring what are operators, right? So to be precise, operators, they help to perform a computation on data, storage, containers. So what I'll do is I'll take the similar part here. So what we have discussed, the transmission delay. So how you can calculate the transmission delay. So I'll ask my user the data size, right? So I'll say there is a storage container called data size. So integer input, enter size of data. Now input and integer, what are they? So input is a function. So input is a function, right? So what is a function? So function takes something as input and gives back a result. So as of now, right? So technically we're gonna explore it very soon, what exactly it is. But for the time being, this input is a built-in function. So it's gonna take this guy as input. Now int is also a function. So the main task of int is whatever the user will enter, it will be converted into integer. Alright, so integer is a mathematical number. Now same way, I'm gonna take this bandwidth also as input from the user. So enter bandwidth. Now what I'll do is I'll say a transmission delay, which is data size divided by the bandwidth. Now what is this guy divide, right? So guys, this divide is operator. So it's gonna help us in perform a computation. Now I will say print me transmission delay is comma transmission delay. So anyone who has not understood what is this program all about, guys? Okay, so yes, Asim. So when I say operators, of course they are a part of our controller logic. So controller is logical ability. So computation comes as a part of controller only. So now I'll run this program. So enter the size of data. So I'll say it's 200. Enter the bandwidth. Let's say 8. So this is going to give me a result 25.0. Now if you see, the result which I'm getting is 25.0, right? So if I have to come up and say that please print me the type of transmission delay and run this program here. So now what we will see is that the type comes out to be float. So in Python, we got integers. Integers, they don't store decimal values, but floats, they store decimal values, right? Now, if I will replace my formula with two division signs and rerun this same program, so I'll say 200 and then I'll say 8. So what you see is that the transmission delay comes out to be 25, not with dot 0. So when I do a single divide, I get a floating result. When I put double divide, I get integral result. So you need to understand that there are two division operators. So they have a different version of how they're gonna come up. Okay, uh, sort of divide action. Defining the divide action means like what? So this is what you need to do. No, that's perfectly fine. So if you want it, so if you want the output into integers, you put a double divide operator, or else you put a single divide operator. So that is how the difference will come up, right? So now if you see, it's an integer output. So it depends upon
Oh,
us.
oh,
Yes, please.
like earlier we defined the input that is integer. Let's
Yes,
suppose if any user put a float
it
number
won't take
like an
up then.
input, it put 2.2.
It won't
So
it won't take up. So it
how
will
that?
just come up as 2 for us, right? So if you want, you need to come up and define this guy as float then. So you have to specify,
Okay.
right?
So
So
we need, if we run a program, we need to define a multiple things because user can put anything there, float,
of
integer,
course.
and
No,
anything.
no. When you are putting a float, right? So float means if I put the value 10, so it is automatically 10.0. So that's gonna work for me, right? So if you find that there can be floating values, so you write down floats instead of integers. So this way, it's automatically gonna be 200.0, right? So that's gonna work for us, not a problem.
Okay. Yep.
All right. So
Sam, can we take 2001 instead of 2? Sorry, 201 instead of 200? Just for seeing how it shows.
all right,
Uh,
1 instead of 200. So data size should go 1.
200. Yeah, 201 instead of 200.
Okay, okay. So what I'm gonna do next is, so I'll now use this single divide operation, right? So why I'm doing it, because I have taken the inputs as float, and we'll use this floating point result now. So coming here,
If
we'll
you can
put,
use it integer
yes,
like
1
similar
and
earlier.
8. So this goes 0.125. And if I'll now come up with integers, so let's say we are going to have integers, and we do a double divide, and now we run the code. So guys, this is supposed to be 0. So I think both the things are clear now, right? So floating point precisions and integral divisions.
It means if there is a double divide sign and we have a float value, it will remove that float value number
Yes,
behind that, right?
yes, integral number. It has to give you the integral number, not the decimal values, right? So all the values after the dot, so they are eliminated for us.
No,
So
one
this
more
is
thing.
pure
Let's
mathematical
suppose
result now, right? So 1 divided by 8 is 0. So when you
no,
go into precision, then it has to be 0 point something something.
no. We in mathematics we follow a rule like if it is dot 6.6, then we consider it a 1. If it is less than dot 5, then we consider it 0.
No, no. Here it's not.
Understand?
It's not gonna work like that. So that is
Okay.
that is known as ceiling and float, right? So we have to compute it separately. So here 0.579 means 0.579 and not 1. So in computer
Okay.
science, the precision will come into action. But if you want, you can do it. So that's flooring and ceiling. That is not something which will be done automatically for us over here. So that may be a good point, guys, which you need to remember, because there might be some of the mathematical formulas which you might come up in networking part. So when you're doing some of these mathematical operations, so 0.5 does not means that you're gonna move ahead, right? 0.6 does not mean that you're gonna come up with the value 1. So it means 0.6 precision. Good to go. So everyone, guys, good to go. Shall we proceed? All right. So what are these operators now all about? So we got these first segment of operators called arithmetic operators. So what we got? We got plus, we got minus, we got multiply, divide, double divide, and remainder. So this remainder is something which gets confused so many people. Let's say there is a value a which is 10 and a value b which is 3. So I say c is a modulus b. So when I say c as a modulus b, and then if I'll say print me the c, so the value comes out to be 1. 3 threes are 9 and the remainder is 1. So you need to understand remainder 1. So I'll just try to come up and rerun the code here. Let's say 208. So this remainder, if you can see guys in the output, this comes out to be 1. So remainder is given by modulus operator. We call it modulus. So I can write down this term modulus. So other than this, plus, minus, multiply, divide, now everything is purely mathematics. I hope we know to demonstrate that. So you can just try looking into them, how they're gonna work for us. But very quickly, I would like to take one more demo on operators, so how they work in the software industry as well. So let us create a new Python file, session 2a. So I'll take one amount as input. So this may go as floating point, right? So enter billing amount, right? So we're gonna enter some billing amount, and after we have entered this billing amount, so we want to compute some taxes, right? So let us say taxes are 20% or whatever the percentage of taxes you want to calculate. So taxes goes like, let's say I'm gonna take 0.5 multiplied by the amount, right? And thereafter I can say that the final amount shall be amount plus the taxes. So print me final amount is \u 20b9 comma the final amount. So let us see what this \u 20b9 will do for us. So when you run the code here, okay, so I think I did some mistake here. So my bad, this has to be input and then the float. Just skip one step here. Okay, so here we are. So I need to take the input and then I need to convert it to float. So that was my bad that I was doing it directly. So the billing amount is 357.89 and this is the final amount. And what you see is an Indian symbol rupee coming up, which is not there on my keyboard, right? So it's not there on my keyboard, and at the same time this guy \u 20b9 is giving up this guy for me. So Python supports Unicodes. So when I say Unicodes, so they are hexadecimal codes. So you can find a list of hexadecimal Unicodes here. So you can say Unicode table. So this is the Unicode table, even all the WhatsApp smileys, etc., right? So they're all Unicodes. So this is a universal standard that how you are going to write a character. So everything you can find here on this table. So I'm just gonna share this link over the chat. You can copy and explore this. So for every you see character, there will be one of the codes. So it's loading more of the things here. So even we have our Devanagiri, that's like Hindi, Gujarati, Tamilian. So all these languages, they will come up for us. me show you. So we have skipped this part of Urdu, and very soon we have entered here, right? So K. So when I clicked on this guy K, it says it's a Devanagari letter, and this is 0915 is its Unicode. So if I come here and I say 0915 and you run the program here, so what you see is this Unicode K. So guys, I think Unicodes are also clear to everyone, right? So if you want, you can use some special symbols while doing programming, and that can be taken care only if you know the hex codes, and they can be available on the unicodetable.com. All right, so this I have shared. Now moving ahead, we'll explore the other operators. So we have a lot of operators. Now we'll explore them one by one. So this is one of the programs which I have shared, that how operators are used to compute a small, result when it comes to real life applications, right? So even if you want to calculate the taxation part, so this way this becomes easier. All right, so now let us come here and see the next version of operators. So now I'm gonna perform assignment operators for all of us. So let's see what are assignment operators. So you got assignment, which means we are going to perform either a write operation or an update operation. Then we got plus assign, minus assign, multiply assign, divide assign, modulus assign, so on and so forth, right? With all the arithmetic operators. So let us say that there is a number, then I'll say assign 10. So what exactly this means, right? So assign, so this guy assign operator shall perform write operation, right? And even the update operation for us. Now when I'll say number is number plus, let's say 20, and then I'll say print me the value of number. So what do you think, guys? What is the value of number now? So number here is number. What is the value of number? So this is a very basic mathematics, that what you're doing is you are adding 20 to the previous value of number, and then you are getting a new result which is substituted into the number. Since number is a storage container, its value can be manipulated. We also call it as a variable. All right. So number here is 30 now. So instead of writing this statement, I can even say num plus assign 20. Now this statement is exactly the statement which we wrote above, but it's a shortcut hand when we have to implement in a quick way. So now if I run the code here, so this gives me the value as 30. So it's exactly the same, right? So there is no difference of using it as num assign num plus 20 or num plus assign 20. So guys, I hope this statement is clear to everyone. So if this is clear to everyone, then let us come and try to explore one more part. So I even would like to put one more operator called double star. So in the arithmetic operators, we can take this guy as 2 stars. All right, so I'll just explain it over here in 2b. Now I'll say num assign 2 multiply with 3, or let's say, yeah, with 3. Now I'll say print num is comma num. So guys, let us see what's gonna happen. So I'll say num is 2 double multiply by 3. The way you got double divide, the same way we got double multiply as well. So it says num is 8, right? So this is what 2 power 3. So you need to understand this computation is what 2 power 3. So it's an exponential computation which we can do. So this is something which I wanted to take up. So this is a part of this session number 2. All right, so one additional part. Now I'm gonna write few snippets, so you just need to answer me what is what, right? So num is by default 1, 2, num multiply assign 2, and then I'll say num double divide or modulus assign 3. So print me number now is comma number. So guys, tell me what is the value of number now. So what should be the value of number at line number 14? So what should be the output here? I'm expecting a result from all of you. Okay, so there is in between query. So include and exclude are also operators. Sort of include, exclude. What include, exclude exactly?
Because in networking term, we are majorly going to include and exclude something in. So for us, it's not in integer; it's on a string. When we focus about string, so just want to know they are the operator also. Don't want any program, but just want to confirm it.
Include and exclude on strings. You have read them in Python somewhere?
No, actually, because when we run some command, we just want a specific output. It's on there are
Okay,
hundreds lines output. We just want some specific output.
correct.
So we use include and exclude things
Okay, so
majorly.
you
Just
want
want
that
to
in
yeah.
the data something should be included or something should be excluded, and then you should get the
So
results.
yeah, so I just want to know those are also operator. The
No, no,
different
no.
input is
They are
different.
functions.
Not it's
They are
yeah. So just
functions.
yeah.
They are functions. So what they're gonna do is they're gonna find out your data, and then
Okay.
they're gonna give you some result. They are kind of functions, but not operators.
Okay, not operator. Okay.
Yes.
So when you go to the function, that just give the what is the difference. So just for understanding sake. So
Yes.
we are not going to discuss it.
Now
Okay.
see,
Yeah.
operator is very much what mathematically we have studied in our childhood days. So when I say operators, they're gonna perform operation on data, right? So data is in front of us, 1, 2, 3, all these values. When I say function, function literally means that it's gonna process your data with so many logical abilities. For example, I want to find the shortest distance. Now there can
Okay.
be some rules that I want to find the shortest distance provided least traffic, right? So here
Okay.
operators won't come up. You need to do something more than the operations. You need to write some conditions. You need to check for if and else part. So functions, they are not just gonna
Okay. So
perform
okay.
mathematical operation. They're gonna do some more part for you.
Okay. Got it. Thanks. Yep.
Very soon we're gonna come up on that. Very soon. All
Yep.
right.
Thank you.
Yes.
Yep.
So guys, I think I got two of the outputs till now. So Asim said 0 and Vinay said 1. So you're into binary now. Of course, we will be into binary. But here, expecting more acknowledgements. Okay, so what I think is we should run the program itself. So number is 1. When I say number plus assign 2, number became 3, right? And then we computed the values, right? So I think who won? So Asim said the correct part, right? So you can just print out the values if you want. So number now is comma number. Then moving ahead here. So number became 9, and when you do a modulus assign, what you're doing is you are basically performing a remainder operation. So you're saying number assign number modulus 3. So what exactly this will mean? Number assign number modulus 3. So when I say 3, 3's are 9, so remainder becomes 0, and here you get the output as 0. So good to go with everyone, right? So what are these assignment operators, right? So assignment operators, they're gonna help us for writing some shortcut way of coming up to the results directly when you have to do some assignments. Okay, so now let us proceed further. So a new Python file, and now we'll have this as session of 2C. Okay, my bad. So just give me a moment. So we'll see comparison operators now. So many times you need to come up and do a comparison on, right? So how you do comparison? So let us say that there is a party A vote count. So that is some number, right? So this is the vote count of some party A, and there is a vote count for party B. So there are two political parties who have some vote counts, and we wanna compare that who actually won, right? So I'm gonna say print are votes equal. So that may be the first question. So you wanna check. So I'll just say comma and I'll say party A vote count equal to party B vote count. So in our mathematics we use single equal to operator to check the equality. So we just say equal, but here in computer science you need to use double equal to for equality check. Now these comparison operators, so they're gonna help us in yielding the result as true or false. So they'll just come up and say whether the result is true or false. So that's kind of a boolean we say, right? So boolean or logical, only two values, 1 or 0, true or false. So are votes equal? Now there can be one more comparison. Are votes not equal? So I'll just put a not equal to. Then there can be will party A win? So I can say party A vote count should be greater than party B vote count. Now when you run the program here, so it says R vote equal false, right? So this gives me the value as false when I say double equal to. Then R votes not equal, so I'll say not equal, which means it's gonna come up and give me true. Why? Because they are not equal. So these are all logical now. Will party A win? Yes, true. Why? Because the number is greater here when it comes to the party A vote count. Exactly. So when I say single assignment operator, that is to assign, it means what? It means that we are going to perform the operation of write or update. But when I use double equal to, it's an equality check. So we're gonna check for the equality. So guys, what and all other operators do we have? So we have greater than, less than, greater than equal to, less than equal to, not equal to. So these are some of the comparison operators which we can use when it comes to perform a comparison. So can we get some examples on how you can use these operators in networking?
Yep. We can compare the routing table. We have that routes.
Exactly. Yes.
Yeah.
So all these see now when I have to come up and use these operators, they become very meaningful. Consider a point that you have a list of, let's say, ages. So there are so many different people with different ages, and you want to sort them in an ascending arrangement. So I need this greater than less than operators to compare the ages and to tell that who is on an ascending level, who is on a descending level, right? So comparisons, they will come up when we are into e-commerce websites. So there we try to apply filters, sort on the price range, lowest to highest. So how that will happen? So that will happen only when we have these greater than and less than operators working for us, right? In the logical environment. So we have these operators. So they will be used to solve different kind of problems. And now on session number 2D, so we got logical operators. So typically when I say logical operators, I got these operators as and, comma, or. So let's see how. So there is physics, the score of physics, which goes like let's say 85. Let me come up on the childhood days. Now these are not my scores. Chemistry is 90. Let's say maths is 80. So I want to come up and put up a decision now for an engineering student, right? So mathematics should play an important role. All right. So if you want to be a core mathematical engineer, so of course chemistry is something which is not required. Or let's say for a computer science engineer, mathematics plays some important role. So I'll just come up here and say print. Can student be a CS engineer? So I might put up a rule now, right? So what rule I would like to apply? So I would like to apply and check that in case the score of maths is greater than chemistry. Now this is one single check that we are comparing the score of mathematics greater than chemistry. So if I'll do a single check, so this guy is saying me false. It says sorry dude, you cannot be. Let's say this goes like 90. Now for 90 also this guy will say false because 90 is not greater than 90. So I can say should be greater than or equal to chemistry. Now this will work for us, right? Greater than equal to versus greater than, I hope that is also clear. Now I'm going to put up one and here. I'll say maths should also be greater than and equal to physics. So guys, what we are trying to understand here is that and means both should be true. Only then I will give you true. If anyone fails, right? So let's say that if your physics score is 95, even your maths is greater than equal to chemistry, but it is less than physics, so this will return me false. So it's a logical and now. So we know what is and. So and is going to come up and give me the result as true. So and yields true result if both conditions are true, right? And how about or? So or means any. So or yields true if any one is true. So if I want to come up and put this statement into an or, it means any one should be true. So if I'll say or, so you run the code here, it gives you true. Okay, so Asim has a query that don't we have direct sort functions rather than having sorting ourselves? Of course, Asim, we do have many things built in and we do write our codes as per our requirements. Now, for example, you want to sort a list of numbers, it's there. So you have routers now and you want to sort routers, the list of routers on some specific parameter. For that, you may not get the built-in function. You may or you may not get the built-in function. So you are writing some customized code for some client, and there you may not get the sort function built in, right? So in customization part. So there you have to work yourself. Okay, so when it comes to not, so guys, when it comes to not, so I'll just come here and I can say an exclamation. So let me try out this part for one of the specific requests. So it's not gonna work for us. So I'll say this not here. So good to go. So not's main purpose will be, so Vinay, the main purpose of not is to convert false into true and true into false. So these are now very much, high level operators. So we don't have the way we have it in C or C++, double ampersand and double, bars and exclamation. So it's gonna work in the same way. So Vinay, I hope your query is also resolved, buddy. Okay. So now guys, let's proceed with the next round of operators. So I'm gonna say a new Python file. This goes like session of 2e. Now I'm gonna work on bitwise operators. So when I say bitwise, they're gonna work on bits. Now this is something which is more of engineering, and you may or you may not need it, but let us see what is that. So A is 8 and B is 12, right? So there are two numbers A and B, and it is represented as 1000 in binary. So whereas this can be represented as 1100. All right. So when I say bitwise operators, so I'm gonna say C is A and B. Then I'm gonna say D is A or B, and E is A XOR B. So guys, these are a few bitwise operators, and we do have more. Explore them, right? So how they're gonna work? Let's see that part first. So and says where both of the ones will come, I'll give 1. So hence everything else becomes 0. So or says any one, I will give the 1. And exclusive or says strictly 1 0 and 1 1. So this becomes 0, this becomes 1, 0 and 0. So what is this in decimal number? So this becomes your 8, this becomes 12, and this becomes 4. Right, so let us print C is comma C. Same way, let's print out D and E. So we're gonna run the code here, and what you find is 8, 12 and 4. So when you wanna work on bits, so you might need to perform logical operation on bits. So this is how you can do it with the bitwise operator. So these guys, they work on bits. They don't work on the data directly. So they will first of all move the data as bits, and then they will perform the operations. Now similar to these bits, we have shifting operators. So typically they are meant to perform a right shift and a left shift. So for example, there is x which is let's say 8, and I'll say y is x right shift by 2, and then print the value of y. So y is comma y. And same way I'll say z which is x left shift by 2. So it can be any value, left shift by any value, that depends upon us. So what is this left shift? This typically means divide. So okay, over here, divide by 2 power 2. Base will always be 2. Always remember, base is always 2. So this value will change. Divide by 2 power 2. So this becomes multiply by 2 power 2. So if you say 3, it means it's gonna multiply by 2 power 3. So when you run the code here, so you see y becomes 2 and z becomes 64. So these are, you can say, operators which will save time if you want to compute the power of a number. Of course, the base should be 2, the binary base, only for the binary base, right? And if you want to just do a multiplication for a base, so it becomes more faster, right? Shift operators. So anyone with any query here, guys? The bitwise and the shift operators here. We are good to go with it. All right, great. So let's come here with a new Python file, session 2f. So I'm doing it in the separate Python file so that we don't get confused what is what and what is where. So now I'll say identity and membership operators. So n1 is 10 and n2 is also 10. Now there are some ways how you check for the equality. So I can say n1 equal to n2. Or I can check a non-equality. I can say n1 not equal to n2. Now I can do the same thing with a different approach. But first of all, let us run this code. So it says true and false, right? So I can just try to say print n1 is n2, and I can even say print n1 is not n2. So when you run the code, it gives us the same result. So these are known as identity and membership operators. Now this will work perfectly fine for us. Let's say you have roll numbers. There's a list of roll numbers 1, 2, 3, 4 and 5, and you want to check. So I can say print 1 in roll number. So you want to come up and do a check of a membership, that whether this guy 1 is there in the roll numbers or not, right? So when you run the code, it says true. So guys, you need to come up, and here I'm going to give you one homework. Explore membership operators on multi-value containers. Check where it works, where it not works, and explore difference between double equal to and is. So this you need to come up and do it. Of course you can do that, Lalit, but for bitwise operators, when you have to come up and solve the problem, so that's like ending and oring, which we were doing, ending, oring and XORing. So how relevant it can be on the IP addresses, so that you need to figure out if it is somewhere in some use case, if it is relevant. Okay, so I think Lalit, you are speaking, but your voice is not audible.
Am I audible now?
Yeah, now you are audible, Lalit.
I'm saying like the IP addresses also, they can be expressed in the decimal. So,
Yes.
but in case I am giving A as a value of a IP address and B as another IP address, so are they going to work the same way they did for the normal integer, like value 1, value 2, value 3?
See, the very first thing is, if you give an IP address 1, so you cannot write it like this. So this way, this is something error, you see now, right?
Yes, we are going to put it into that
Double
commas.
quotes. Yes, so it has to be a
Yes.
string now, right? Now, moving ahead for the string, it's not a mathematical data now. So string means textual data. You need to understand the point. So this string means textual data. So if you have to apply the operators, there we need mathematical data. So what we are doing is we're doing these operators, and these operators, they will work on mathematical data and not textual data. All right. So
Okay.
for this, it's not gonna work.
Yeah, Jean, for that, let's suppose that is a string, and if we go to the function in future and
Yes.
prepare something with our conditions, then we can get the output
Yes,
which we
yes,
want.
yes. For an
Yeah.
instance, I'll just give you for an instance. I'll say print
Yeah.
me IP address of IP address 1 of, let's say, 0 colon 3. Now when I will run this program here, so it's gonna give me 192. So I think you guys just got one of the understandings. When I say 0 colon 3, it is giving me 192, right? And I can convert this guy into integer, right? So I can say, let's say a is your integer, IP address 1 of 0 colon 3, and then print down this binary representation of a, and I can even just print out this guy a. So this just to answer the query, right? So I got this guy 192, right? And I got the binary representation 1 1 all zeros, if you see here in the result. And now I can perform the computation the way I want. So it requires a bit of more knowledge on how those specific use cases can be entertained, but they can be. So I think now it's fine. So Lalit and Saurabh, we are good to go, right? Just a quick introduction, right? Let's not get into this as of now, okay? Okay, so now I think we can have a small break, and after the break, we shall proceed into some more of the coding sequences, right? So we'll have small break now.